Hello everyone. In this video, we will learn how to apply array processing to some common programming tasks. We start with learning some useful array functions. Sometimes, we don't know the dimension of an array. This tends to be the case when we use _numeric_, character and all_ as array elements. A handy workaround is using the dim function, which returns the actual dimension. The optional n in the dim function is used to specify the dimension of an array. If the n value is not specified, the dim function will return the number of elements in the first dimension of the array. In the second format of the dim function, bound n is either a numeric constant, variable, or SAS expression that is used to specify the dimension for which you want to know the number of elements in a multi-dimensional array. Closely related to the dim function are the HBOUND and LBOUND functions that return the upper and lower bounds of an array respectively. Program 6.3 uses the dim function to return the number of elements in SBP array. Instead of using the dim function, we can also use the HBOUND function to return the upper bound of SBP array, which is 6. Now, let's see how to use the in operator. This data set is similar to the dataset SBP, except that the missing values are represented by using periods. Suppose that we would like to create a variable, miss, which is used to indicate whether SBP1 to SBP6 contains missing values. This task can be easily accomplished by using the in operator. The in operator can be used for searching for numeric or character values in an array. If the searched value is found, the in operator returns 1, otherwise, it returns 0. Program 6.4 illustrates the use of the in operator with SBP array to create the miss variable. We can pass an array on to most functions with the of operator. Suppose that we would like to create two variables, SBP min and SBP max, that contain the minimum and maximum SBP values for each person. We can use the min and max function with the of operator to accomplish this task, like in problem 6.5. Please keep in mind that we need to use an asterisk as the subscript within the function. Here's the printed output from the previous program. Now, let's see some examples of using array processing. Suppose that the first three measurements of SBP are recorded pre-treatment, and the last three are recorded post-treatment. Furthermore, suppose that the average SBP values for the pre-treatment measurements are 140, and that the average SBP is 120 for the measurements after the treatments. Based on this data set, we would like to create a list of variables, above 1 to above 6, that indicate whether each measurement is above or below the average measurement. We will use 1 to indicate the measurement is above the average, and use 0 to indicate the measurement is below the average. Here's the solution for solving this problem, by using the array processing method. In this program, the first array statement in program 6.6 is used to group the existing variables, SBP1 to SBP6. Since SBP1 to SBP6 existed in the input data, there is no need to specify these variables in the array statement. The second array statement creates 6 new variables, above 1 to above 6. Since above 1 to above 6 variables do not exist in the input data, this array statement will create these variables. The third array statement creates temporary data elements that are used only for comparison purposes. These array elements are initialized with 6 values. The first 3 values are the average SBP values for the pre-treatment measurements, and the last 3 values are the average SBP for the measurements after the treatments. The if-then statement within the iterative do loop is to compare each element in the SBP array with each element in the threshold array to assign values to the elements in the above array. Let's see another example. Suppose that we would like to calculate the product of a list of numeric variables. We can use array processing to accomplish this task by grouping numeric variables into an array. We need to make sure to treat the missing value as 1 during the calculation. In the data step, we can start assigning the first element of the array to the result. Next, we need to create a loop to iterate from the second element to the last element of the array. Within the loop, we multiply the result with each element of the array. Transforming a data set with one observation per subject to multiple observations per subject, or vice versa, was introduced in Chapter 3 and Chapter 4. The solutions in the previous chapters are not efficient if we have large numbers of variables that need to be transposed. A more effective approach is to utilize array processing. For example, this program transposes dataset wide to dataset long. Now, let's see how to modify this program by using array processing. First, we need to group the variables S1 to S3 into the array S. Within the program, instead of using variable names, S1 to S3, we need to change them to array reference, S1 to S3. The three almost identical blocks can be placed within an iterative do loop by using the time variable as the index variable. That's all we need to do to change this program. Here's the modified version of the program by using the array processing. Now let's see how to transform data from the long format to the wide format. We saw this program in Chapter 4. We can modify this program by using the array processing method. Again, we need to group S1 to S3 into an array by using an array statement. Then we need to use the array references in the program instead of using the variable names. When reading the first observation of each subject, that is when first.id equals 1, we can use an iterative do loop to initialize each element in the array to missing. To modify the multiple if-then statement, we need to understand the contents in the PDV at each iteration of the data step execution. For example, when SAS process the first observation, the time variable equals 1 at this point. When the if-then statement executes, S1 is assigned with the value from the score variable. S1 is equivalent to S_time, by using the time variable as the subscript in the array reference. When SAS process the second observation, the time variable equals 2 at this point. When the if-then statement executes, S2 is assigned with the value from the score variable. S2 is equivalent to S_time also. Therefore, the multiple if-then statement can be rewritten as S_time equals score. Here's the final version of the code by using array processing. Now, let's review what we've learned from this video. In this video, we learned several array functions, including dim, HBOUND, and LBOUND functions. We also learned how to use in and of operators with an array. Then we went over some applications of utilizing array processing, such as creating a group of variables, calculating products of multiple variables, and restructuring datasets. I hope you enjoyed this video. Please subscribe to my channel and click the bell icon to get new video updates.